Here are some examples of problems about trigonometric identities. Problem 1. Find the value of cotangent theta if tangent theta equals 3 and 0 is less than or equal to theta, which is less than or equal to pi over 4. To solve this, we can use the reciprocal identity, which tells us that cotangent of theta is equal to 1 over tangent of theta. And since we're given that tangent of theta is equal to 3, this is just equal to 1/3. And that's the answer. Problem 2. Find the value of cosine theta if sine theta is equal to 2/3 and 0 is less than or equal to theta, which is less than or equal to pi over 4. To solve this, let's first use the Pythagorean identity, which tells us cosine squared theta plus sine squared theta is equal to 1. Now we know that sine of theta is equal to 2/3, so if we plug that in, we get cosine squared theta plus 2/3 squared equals 1. So cosine squared of theta is equal to 1 minus 2/3 squared if we subtract 2/3 squared from both sides. And this simplifies to 1 minus 2 squared is 4 over 3 squared, which is 9. And 1 minus 4/9 is 5/9, since 4 plus 5 equals 9. Finally, we know that cosine of theta must be equal to plus or minus the square root of 5/9. The square root of 5/9 is just square root of 5 over 3. But since we know that theta has to be between 0 and pi over 4, we also know that cosine of theta must be positive. This means that cosine of theta is equal to positive square root of 5 over 3. Problem 3. Find the value of tangent theta if cosine theta equals 4/5 and 0 is less than or equal to theta, which is less than or equal to pi over 4. The first thing we can do here is use the Pythagorean identity that says cosine squared theta plus sine squared theta is equal to 1. Now just like in the previous problem, we can plug in 4/5 for cosine theta and get 4/5 squared plus sine squared theta equals 1. This will allow us to solve for sine theta. We'll get that sine squared theta is 1 minus 4/5 squared by subtracting 4/5 squared from both sides, and this equals 1 minus 16 over 25. Now 25 minus 16 equals 9, so this gives us 9 over 25. Then we get that sine of theta is equal to square root of 9 over 25. We take the positive square root since 0 is less than or equal to theta, which is less than or equal to pi over 4. And this is equal to 3/5. Now that we have sine theta, and since we were given cosine theta, we can use the identity for tangent, which states that tangent theta equals sine theta over cosine theta. Now plugging in the values we already have for this, we get 3/5 divided by 4/5. The fifths will cancel out and we'll be left with 3/4, which is tangent theta. Problem 4. Simplify the expression tangent squared theta minus sine squared theta over tangent squared theta times sine squared theta. Starting with this expression, we have tangent squared theta minus sine squared theta over tangent squared theta times sine squared theta. And now we can use the distributive property to split up both terms in the numerator. The first term will be tangent squared theta over tangent squared theta sine squared theta. But here the tangent squared will cancel and we'll be left with 1 over sine squared theta. Similarly, the other term we'll get is sine squared theta over tangent squared theta times sine squared theta, which is just 1 over tangent squared theta. Now we also know that 1 over sine squared theta is going to be the same as cosecant squared of theta, since 1 over theta is cosecant theta. Similarly, 1 over tangent squared theta is going to be equal to cotangent squared theta, since 1 over tangent theta is cotangent theta. Finally, we can use a Pythagorean identity to replace cosecant squared theta with cotangent squared theta plus 1. So we have cotangent squared theta plus 1 minus cotangent squared theta. The cotangent squared thetas will cancel, and we're left with 1.